Question 33 is asking me to use coordinate geometry to determine if this triangle is scalene, isosceles, or equilateral. So what I'm going to have to do is find the lengths of all three sides because that's what these terms mean. Scalene means none of the sides will be the same, isosceles means only two of them will be the same, and equilateral means that all three of them are going to be the same. So to organize my work, I'm going to list down, I'm looking for BF, I'm looking for BH, and I'm looking for FH. Now just looking at it, it appears to me that this could be isosceles because BF and BH might be the same, but FH looks very much longer to me than the other two. So let's start by finding BF and BH. Now you could do the distance formula, but I'm a bigger fan of just counting up and over and then doing the Pythagorean theorem. So if I'm finding BF, I'm going to count up 1, 2, and then over 1, 2, 3, 4, 5, 6. Hopefully I counted that right. So that would be 2 squared plus 6 squared should give me the diagonal BF squared. So I need to square root to figure out that actual length. So I'm going to get 4 plus 36, which is the square root of 40. I can reduce that to 2 root 10, but all I'm really looking for is if I get something that comes up to square root 40 again. So now I thought it was the same as BH, so I'll do that one next. If I sketch this triangle from H to B, I'm going over 1, 2, and then I'm going up 1, 2, 3, 4, 5, 6. Again, hopefully I counted that correctly. So it was over 2 and up 6. So that's going to be 2 squared plus 6 squared. And I can see right here, 2 squared plus 6 squared is going to be the same thing that I got before. So I have 2 root 10 and 2 root 10 for BF and BH for their lengths. Now FH is the one that I thought was not the same, but I can't just assume that it's not. I need to find that length as well. So let's figure out what FH is. Looks like we're going down 1, 2, 3, 4, 5, 6, 7, 8, and then over 1, 2, 3, 4. So that would be 8 squared plus 4 squared to find that hypotenuse FH squared. So remember, you always have to square root that to find just the length of FH. So that's going to be 64 plus 16, which is going to add up to 80. And the square root of 80 is, what is that, 16 times 5, so 4 root 5, which is not the same as the other two. So right here is where I'm going to say that is definitely an isosceles triangle. And if you don't show me all three lengths, there's no way that you would be able to determine that. So please show me that work when you're answering this question on your test. Now the second part of the question says, is this a right triangle? Well, this is testing, do you remember how to find right angles? The only one that looks like it could be a right angle would be angle B. So what I'm going to check is the slope of BH, and I'm going to compare that to the slope of BF, because if these two run into each other in such a way that they're perpendicular, then that is a right triangle. And perpendicular lines have slopes that are opposite reciprocals. So I'm looking for opposite reciprocals. So if I'm looking for the slope of BH, that would be 4 minus a negative 2, y minus y, over negative 1 minus 1, which would end up being 6 over a negative 2 or a negative 3 for that slope. Now, you'll notice those same numbers, 6 and 2, those are the same numbers we were using in our distance formula. So we can use those same numbers, but you have to pay attention to the numbers before you reduce it. The slope is negative 3. So if I'm looking for the slope of BF, I'm going up 2, so that's positive 2, and then I went to the right 6, which would be a positive 6. So again, the same 2 and 6 that I used to get the distance, but in slope it matters where those numbers go. So 2 over 6 reduces to a positive 1/3. Well, negative 3 and 1/3 are in fact opposite reciprocals. And if those are opposite reciprocals, that means that those are perpendicular. And if it's perpendicular, angle B is a right angle. So it is isosceles, and it is a right triangle. And this is the work that I would need to show to prove that.